Assalamualaikum and good morning, madam. Today, I and my friend will presenting on high voltage technology assignment 2. So we will presenting and I will give some introduction for cockroach Walton multiplier circuit. So this is my group mate Muhammad Nur Azim. Uh, Second name is me Muhammad Arif Ikhwan, and third is Muhammad Fakrullah, and fourth is Muhammad Iqbal Daniel. So next, so we through the agenda, I will introduce the introduction, and my other groupmate will explain the theoretical principle, design consideration, simulation result, and conclusion. So for introduction, the Cockroach-Walton circuit convert low AC or DC input to high DC voltage using capacitor and diodes. Invented in 1932 by Cockcroft and Walton, it used in X-ray machine, particle acceleration, and industrial application. The design eliminates bulky transformer, providing a scalable solution for generate high stable DC voltage. For more information, the Cockcroft-Walton circuit is specifically designed to generate high DC voltage from lower AC or passing DC input. What makes it remarkable is its ability to achieve this without large, heavy, and expensive transformer. Instead, it uses a unique and efficient design that combines capacitor and diodes in a systematic way to amplify the input voltage step by step. The circuit operates in stage, where each stage consists of capacitor and diode. These components work together to store and transfer electrical charge, incrementally boosting the voltage. The more voltage and more stage added, the higher the output voltage can become. The scalability makes the circuit assembly versatile and adaptable for different applications. One of the key advantage of this design, simplicity and cost efficient compared to other methods of generating high voltage, such as using large transformer. The Cockroach-Walton circuit is more compact and economical. This is makes an ideal choice for application and required high DC voltage but need to minimize cost and size. So for the circuit application, it has a wide range of application in both research and industry. For example, it is a critical component in particle acceleration or X-ray machine, where high DC voltage are essential. You will also find it in devices like cathode ray tubes, electrostatic paint, and laser system. Even photocopy and medical imaging equipment, the Cockroach Walton circuit play a vital role by providing the stable high voltage needed for their operation. Beyond a versatility, the circuit is also known for its durability and reliability because it doesn't rely on it has fewer points or for failure, making it long-lasting solution in high voltage system. In summary, the Cockroach-Walton voltage multiplier is an ingenious and highly practical invention in high voltage technology. Its ability to generate evaluated DC voltage efficiently using a cascade of capacitor and diode has made is a fundamental tool in field ranging from industrial process to medical equipment. By understanding the principle and operation of this circuit, we gain valuable insight, designing solution at required high voltage DC power. So thank you for your attention. I will now pass to my group mate who will explain the others content. Thank you.
Assalamualaikum madam. My name is Muhammad Morgan Alam Malik. Okay, I will continue about theoretical principles. The Cockroach-Walton voltage multiplier is a circuit that increase an alternating current AC voltage to a much higher direct current voltage It used a combination of diode and capacitor to achieve. The circuit consists of several stages, with each stage having a capacitor and a diode. When AC voltage is applied, the capacitors get charged in a specific order through the diode. Each stage adds more voltage to the total output, so the voltage increase with each additional stage. The number voltage, the total output voltage depend on the input voltage and the number of stage in the circuit. The formula to calculate the output voltage is V out equal to N times V in. V in is the peak input voltage, N is the number of stage. Ripple voltage is a small fraction in the DC output. It happens because capacitor can only store a limit amount of charge. The ripple voltage depends on the load current, the capacitor size, and the AC frequency. Then efficiency, the circuit loses some energy due to imperfection in diode and capacitors. This means the output may not always be perfect. Heavier load, more current drawn, can also lower the efficiency. In simple terms, this circuit is like a step ladder for voltage. It starts to low voltage and keeps adding small amount with each step into until it reaches a very high voltage. However, to work well, it needs good quality components and careful design to avoid voltage fluctuation. Okay, next. This is a design consideration. Design depends on stage, capacitance, and diode properties. More stage increase voltage but cause higher losses and ripple. Larger capacitance stabilize output but raise cost and size. Diode need high peak inverse voltage (PIV) ratings, low leakage and fast recovery. Balanced design ensures efficiency and minimize performance losses. That's all for me. Thank you. I will pass to my group mate.
Okay, thank you, Muhammad Farullah. Hello, my name is Muhammad Nur Azim, and I will be presenting about simulation result. Next slide. Okay, based on simulation result, we have to create an 8-stage circuit that was simulated with a 0.05 microfarad capacitor and a 5 milliampere load and a 12 kilovolt AC input. The output voltage was 490.67 kilovolt with ripple voltage at 75%. Voltage drop was significant in higher stages, confirming theoretical limitation. All the numbers that has been produced in the slide has been calculated onto a paper. Optimization of stages and components can improve stability and reduce output variation. Next slide. Okay, based on the simulation calculation, we first have to calculate the theoretical one. So based on the assignment, we have to gather our 4 group members matrix number, 3 number at the back. For Arif, we generate 10 kilovolt, and for me, that is 18 kilovolt, and for Abdullah 14 kilovolt, and Iqbal 6 kilovolt. So in order to gain the VS, we have to find the VS average. We total up all 4 of our matrix number and we get 48 kilovolt, and the 48 kilovolt will be divided by 4 to gain the average value, that is 12 kilovolt. So our N is 8, representing 8 stage of Cockroach Walton, and C is 0.05 microfarad, and the frequency is 50 Hz, and the I is 5 milliampere. So for the first one is we have to search for percentage of ripple voltage. In order to gain percentage of ripple voltage, we need to gain ripple voltage first. So based on the calculation, this is a ripple voltage calculation. The formula is I over 2 FC times by N and N plus 1. So I is 5 milliampere over 2 times 50 times 0.05 micro times by 8 and 8 plus 1, and we will get the ripple voltage, that is 72 kilovolt. So in order to get the ripple voltage, we need to multiply by 2. So by multiplying 72 kilovolt with 2, we get 144 kilovolt. Next slide. So to get ripple voltage, the ripple voltage will be divided by 2n Vmax times by 100. Vmax is based on the average that we has calculated before. So 144 kilovolt over 2 times by 8 times by 12 kilovolt and multiply by 100%, and we will get 75% for ripple voltage. And for the output voltage drop, the formula is I over Fc times by 2 by 3 times by n to the power of 3. So 5 milliampere over 50 over times by 0.05 micro times by 2 over 3 and times by 8 to the power of 3, and we will get the output voltage drop, that is 682.67 kilovolt. Then we will proceed to the regulation voltage. So to get regulation voltage, the output voltage drop will be divided by 2n Vmax times by 100%. So 682.67 kilovolt will be divided by 2 times 8 times 12 kilovolt times 100%, and the regulation voltage is a bit high because of the Vs average is small. So we will get 355.557%. Next slide. So for optimum stage number, the formula for n optimum is square root Vmax times by Fc divided by I, and we will get 2.45. For consideration, it will be 2, and then we will calculate the simulation of ripple voltage. This is based on ripple voltage value. So Vmax minus Vmin over by 2. In order to get Vmax and Vmin, we need to get from the simulation result. So based on the simulation result, the Vmax is 82.216K minus Vmin 78.851K divided by 2, and we will get 1.683K, and the maximum output voltage is 2n Vmax minus output voltage. So 2 times 8 times 12K minus 682.67K, and we will get the result negative 490.67K. So in consideration of the negative, we will put the positive answer, but we must not neglect the result. So the negative will be included in the result. So simulation of voltage drop is 2 times n times Vmax and minus Vmax. The Vmax in the bracket is the one that we count for Vs average. So 2 times 8 times 12K minus the Vmax from simulation, that is 82.216K, and we will get 109.784 kilovolt. Next slide. Okay, this is the circuit diagram of 8-stage Cockcroft Walton voltage multiplier. As you can see, there are 16 diode and 16 capacitor. In order to get the 8 stage, 16 over 2 and we will get 8. Therefore, this is an 8 stage Cockcroft Walton. Next slide. Okay, this is the simulation result for river voltage, and based on the river voltage we will gain the Vmax and the Vmin. If you can see, the red one is 82.216k, representing Vmax. And as you can see, for the blue one is Vmin, 78,851k. Next slide. Okay, this is a simulation of voltage drop. Even though Madam didn't ask us to produce the graph, I wanted to show that how the voltage drop is captured during the circuit diagram. So by putting two probe at the end of the capacitor, I mean diode, I mean capacitor, you will get the result for the voltage drop. The red graph represents the voltage drop. Next slide. Okay, the conclusion will be presented by my colleague, that is Muhammad Irfan. Thank you.
Assalamualaikum, and thank you for my friend Muhammad Nawazim for the explanation. And my name is Muhammad Badinal bin Mazhar, and for this one is conclusion. And for the conclusion, the Prof. Walton circuit is a compact, efficient solution for generating high DC voltage. Partial performance due to ripple, diode, loss, and real-world intersections. By addressing this challenge through design, optimization, and simulation, its performance can be enhanced to meet various partial requirements. Its versatility and reliability make it indispensable in application like medical imaging, particle accelerator, and industrial power supply. Ultimately, the circuit underscore the critical need for aligned theoretical design with real-world consideration to achieve robust and efficient solution in modern electrical system. It's important to balancing the theoretical model with practical execution. And that's all conclusion for our assignment for my group. Thank you.
That is all. Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.